So lesson number 7 is more problem solving using trig ratios. So what we're looking at is problems where there's 2 right triangles and I have to solve information or use information from one right triangle to solve something in the other right triangle. The big thing that we need to realize is when this situation arises, we do not round the intermediate answers. If we're going to stop those intermediate answers at any point, we need to have about 5 or 6 decimal places. But we try to keep them in our calculator as much as possible. So I'll grab my calculator and pull it up so that so in this diagram for class example number 1, the length of Q to S is 32 millimeters. Angle PQS is 50 degrees. Angle RPS, so RPS would be this angle up here, is 61 degrees. And the question is, what is the length of QR? So what is this total distance? So how would I determine, what would I need to know to find the length from Q to R?
You have to find what R to S is.
So I need to find RS. So if I look at this triangle RS, or PRS, the only piece of information that I have from that triangle is I have an angle measurement. I need at least 2 pieces of information from a triangle in order to find more. And if I'm talking about side lengths, I need an angle and a side. If all I have are 2 angles in a triangle, I cannot find anything. I need to have at least one of those side measurements. So is there a side measurement from triangle PSQ that I could use to help me solve for PSR? PS or PRSP. So we're going to start off with finding PS. So how can I go about finding the length of PS? What could I use? I could use tan. Thank you, Taylor. So tan of what? Tan of 50 degrees. X over 32. So instead of X, I'm actually going to use the letters PS, just because then I'm a little bit more certain of what exactly I'm calculating. So how do I get PS by itself? Okay. And when I go 32, 10, 50, what do I get? Just start it off.
38.136.
So that's to find PS. Now that I have PS, I can use that to find RS. What do I need to find RS? Or how would I find RS? What would I use? Tan? Tan what? Okay. And that would equal the opposite side, which is RS, over this adjacent side of PS. And I have PS already. That was my 38.136. So how do I get RS by itself? So if this was on my calculator, I start off with my 32 tan 50, and there's my 38.136, and then I'm going to take that and multiply it by tan 61. So the minute I hit the multiplying sign, A and S comes up. I don't necessarily have to go second and the negative button. it will pull that previous answer anyways. And I get 68.799. So to the nearest millimeter would be how many millimeters? 69 millimeters would be the length of RS. But that's not the length of RQ. RQ would be the 69 plus the 32, which would be what? Okay. I'm going to give you about 3 minutes. I want you to start working on class example number 2. You're going to calculate the measure of angle BEC. So just to label that, BEC would be this angle right in here. So what information do I need in triangle BEC to find out this angle? What will I need to know? Like BC? EC? Yeah, if I find out EC, I can use one of my trig functions because I have a side. I have 2 sides, so I could use a trig function to find the angle. And I would choose EC over BC because EC is shared with this triangle. So if I use triangle ACE, how do I solve for EC? What trig function? Okay. So sine of a 39-degree angle would be EC over 3.7. So then I can multiply. And what is 3.7 times sine 39? Anyone to write that step down? 2.3284. And then what trig function would I use in my second triangle? So this would be the cosine of angle E would equal the adjacent side, which is my 2.32, over 4.6. And to find out angle E, I would have to cos inverse it. So if I put this into my calculator, I start off with my first step, my 3.7 sine 39, or 3.7, sorry, sine 39. So there's my 2.328. And then I need to go cos inverse this answer. So if I go second and the negative button, the answer will come up, divided by 4.6. 59.589. So 59.589. How many degrees is that? 60 degrees. Next example. In January 2003, the tallest building in Rockyville was the Metro Building. Recently, a developer was commissioned by Gamma Pro Oil Company to build a taller one next to it. From the top of the Metro Building, the angle of elevation to the top of the Gamma Pro Building is 24 degrees. From the Metro to the Gamma, the angle of elevation is 24 degrees. And the angle of depression to the foot of the Gamma Pro is 56 degrees. So my 56 degrees would be this part in here, angle of depression. If the buildings are 45 meters apart, determine the height of each building to the nearest meter. So we've labeled the parts of this question. What I want you to do again is I'll give you a couple of minutes. I want you to actually go through and solve it. So where do I start? Okay, so which triangle am I using? Am I using this one or am I using this one? Or does it matter? Okay, so if this is the triangle I'm going to use, this distance here is still going to be the 45 because it's the same as the distance at the bottom. So I want to find this length here is going to be the Metro building. So I can use tan. Okay, so tan 56 will equal x over 45. So what is 45 tan 56?
66, 47, 1, 5.
So then that means that the Metro building (67 meters) tall. Okay, how do I find the Gamma Pro building?
Just add the extra. Use that triangle at the top. Just add it.
So I would find this part here, we can call it y. What trig function would I use? Tan again. So this time it would be tan 24 is y over 45. And I would multiply. And what is 45 tan 24?
20.035.
So then to find the Gamma Pro, I need to add this 66.71 to this 20.03, which ends up giving me 86.74. So how many meters would that be?
87.
87. Okay. So I want to skip to the problems in 3D and then I'll give you the questions for the whole assignment. Solid in this diagram was formed by taking a rectangular prism and removing a wedge. So it's not a triangular prism. It would be almost in a sense like taking kind of a triangular prism and cutting a chunk off of it. So this part has been shaved down. So the height from G to C is not the same as F to B. H to D and G to C is 5 centimeters. So this is 5 and this is 5. E to A and F to B is 2. So it goes from 5 centimeters to 2 centimeters. From A to D is 6, and A to B is 8. Give me a rectangle in this shape. Use the letters to tell me what a rectangle would be. So I'll give you one. A, B, F, E would be a rectangle. Give me another one.
D, C, G, H.
Okay, so that's the front and the back. Are the side pieces going to be rectangles? No. Okay. So the two sides are not. Is the top a rectangle? So what would be the demand? What would be my classification for the top? E, H, G, F. Is the bottom a rectangle? So what would that wouldn't be called?
A, B, C.
So the question that we're asked is to calculate the measurement of angle HEA. H to E to A. So what I'm going to do is I'm actually going to pull this panel out and redraw it. The way that panel looks is I've got a measurement from H to D. That was 5. And then it travels along for 6 centimeters. And then I have this measurement that's from A to E. That's 2. So how could I figure out what this angle here is? What could I do? Well, right now, to find angles, what shape do I need? What kind of triangle?
The right triangle.
So how can I make a right triangle in this shape? So if I drew a parallel line to DA through E, right? So then I'd have my right triangle here. What do I know about this angle right in here?
It's going to be a 90.
Has to be 90 degrees because we made these parallel lines. So if I figured out this angle in there, I can add it on to 90 and that would give me the whole thing. So how would I do that?
Would you have to divide your bottom, like, rectangle into a triangle? So then you get the co-exterior. So, like, so you take your rectangle and you draw horizontal through it, or diagonal, the other way, like from,
This way?
yeah.
But how is that going to help me find this angle here? Or you're
Or
thinking
no,
then you
but-
do alternate interior?
Yeah, but it's different, yeah.
So let's look at this triangle. What dimensions do I know about this triangle?
The bottom is 6.
Bottom is 6. Can I figure out what this is?
It's half of 3,
It's not half, it's
3.
3. Why is it 3?
because you subtract some people.
Because this from here to here is 2, and the whole thing is 5. So that means from here to here would be 3. I have 2 sides. How do I find the angle? What do I use? Tan. So then the tan of angle, let's call it X, is 3 over 6. So then angle X would be the tan inverse. And what's the tan inverse of 3 divided by 6?
27 degrees.
27 degrees. So then angle HEA would be the 90 and the 27. How many degrees? Good. Question C asks to calculate the measure of angle HFE. So H to F to E. So if I take that rectangle, which was HGEF, HGFE, right?
Would it just be a 90?
No, not, no, it would be a 90. I know that,
You need to add this 8 centimeters.
what I want to know is I want to know the measurement from angle H to F to E. So that's the angle that I want. And I can't necessarily just say it's got to be half of the 90 because I don't know that for sure. What I need to know is I need to know another side length. That would be very useful at this point in time.
No, that puts 6, so you just do my diagonals there.
So say that louder.
Don't you just use Pythagoras theorem with 3 and 6 to find the hypotenuse and I'll actually give you
Okay, so that would be taking this part right here, right? H to E of this triangle. Okay? So that's from H to E, that would be 6 and 3. So then I get 6 squared plus 3 squared equals 45. So then HE would be whatever the square root of 45 is. And it's probably easier for me to just leave that as the square root of 45 than to write it down as 6 point something. Because there's going to be a lot more decimals that I have to try to hold in. So now we're going to label that just as the square root of 45. So now I have these two side measurements. How do I find the angle? Tan. Okay? So the tan of this angle, we can call this one y, because we called the other one x. So the tan of this angle y would be the square root of 45 over 8. So then angle y would be the tan inverse. The only thing to watch out for, depending on the calculator that you have, some of your calculators, when you press tan inverse and then you go the square root, it opens up a bracket for your square root, and then you type in 45. You have to then close that bracket there. Mine, my bar extends over. So you'd have to close the bracket around the 45 and then divide by 8 and close the bracket again. So if you looked at it from left to right, you'd have an open bracket, close bracket, close bracket. So everything matches up. How many degrees do I get? 40 degrees. So then angle HFE is 40 degrees. So then the last measurement that we're asked to find is angle HBD. So if I go back to that previous picture, I'm looking for H to B to D. So I need this triangle H to B to D. So if I draw that out, from H to B to D, do I know any of the measurements on that triangle? Okay. But I don't know H to B and I don't know H to D. And I need two of those sides. I need another side. So let's go back to that picture. And what I'll do is I'll actually sketch what we want. I'll use blue. So I want angle H to B to D. That's the triangle I'm looking for. So is there anything that I can use on this shape to find out either the distance from H to B or D to B? Pythagoras theorem to find which one, Isa?
D to A 6 squared and A to B 8 squared.
Right here. Good. So if I look at triangle DAB. So triangle DAB. D to A was,
6,
and A to B.
8.
So now I can find DB squared. What is 6 squared plus 8 squared?
100.
So then what would D to B be?
Square root of 100 is 10.
Thank you. So now I can put 10 into here. And what do I use to find that angle? 10. So we'll call that Z. Tan of angle Z is 5 over 10. So 10 inverse. What do I get?
27 degrees.
So then angle HBD is 27 degrees. Did we have another 27 degree angle in this question?
Yeah.
I think part A was 27, right?
Yeah.
What did we divide in 27?
6 divided by 3, so good.
3 divided by 6.
3 divided by 6.
So 3 divided by 6, which is 1/2, gave me the same as 5 divided by 10, which is 1/2. So tan of my 1/2s always give me a 27 degree angle. Doesn't matter what the side lengths are. If the ratio reduces down to 1/2, I'm going to get that 27 degrees. Okay, so the questions that I have for you. Question 1B, 2B, 3, 6, and 8, 9, and 10.